So we're going to solve the second problem. Again, you're supposed to find this time, T2 and T1 and T2. So you write that here. T1 in newtons and B T2 in newtons. Okay? All right. So it's given there. Look at this. Now we look for the vectors. Where's the vector? There's one going down here, right? And that is the Fg. That's the weight. And it's given 600 newtons. Then we have another one going this way, right? It's pulling that way because if not, you cut that, where would it go? It would swing down. So that's going this way. That's your T2. And then this other one, well, it has to be going this way because if not, if it were going that way, all of the forces are now going this way, it would swing. So it has to be holding it back, right? So again, we write a free body diagram. Try to be as consistent as possible. So, going down, Fg. And this way is T2. And your third one is this way. And that is T1. Okay, remember that there is an angle here, right? Which is 50 degrees. Okay, and okay. Now we have to resolve, this is the diagonal vector. And so we have to resolve that this way. This is your T2y, right? And then here's another one. And it's T2x. So once you have the x and y, you don't think about this one anymore, right? This is also 50 degrees. Again, why is that? If you have two parallel lines, this is parallel to this, and it's cut by a transversal, and so it produces equal interior angles. So this is 50 degrees here, right? Okay, so where do we start? We start with letter B, I guess. Okay, so we solve for B. Summation of the forces along the y-axis is equal to 0. So what's going down is Fg. What's going up is T2x, T2y. And what's the formula for T2y? As given here, it's T2 sine of theta. Okay, and why is it sine? Because it's going to be here, it's not touching, right? The x is touching, the y is not. Okay, so we're solving for T2 is equal to Fg divided by sine of theta, which is Fg is 600 newtons divided by sine of 50 degrees. And that T2 is 783 newtons. Okay, that's your B. Write that here. 783 newtons at 50 degrees. And now you're going to solve A, which is T1. And what is it? Summation of forces along the x this time is equal to 0. So along the x, what do we have? We have T1 is equal to T2x, which is equal to, x is there, so it's T2 cosine of theta, right? Okay, and T2 is given there, 783 newtons times cosine of 50 degrees. And T1, if you solve for that in your calculator, it's 503 newtons. And what is the direction? This way is at 180 degrees. Okay? So for those who are not able to do this, I'm going to show you how to do it on the calculator. Okay, I hope you can see this. Let's start with this. Okay? That's 600 divided by parenthesis 50 sine close parenthesis equals. There's the answer. Okay? I'm going to do this one. Look at that. 783 times parenthesis 50 cosine close parenthesis equals. Okay, so verified. How did I get 180? Well, it's going this way, and if you start here and you go all the way there, that's 180 degrees, correct? And how did I get 50? From here going there. Okay? Hope that helps.